I will record this. And again, they're in reverse order of things that we cover. And these are also linked in the modules with closer to the actual assignments that they're relevant to. I do YouTube videos, not Panoptico. All right, I don't like Panoptico. And also, these are then available outside of Canvas if you don't want to go into Canvas. So these are YouTube videos. They are closed captioned if you need that, although they're automatic closed captioning, so it can be anything from a psychedelic experience to fairly good. They're getting better. Their AI for captioning is pretty good now. It used to be that it was just literally word salad. All right, so those are some of the resources that I have. Let's go back to the syllabus. You can stop me anytime you have a question, too. You don't have to listen to me drone on forever. So, we're officially meeting on Wednesdays 10 to 12. As I said, most of them will be open labs, with the exception of the first couple of weeks. All right? In the first couple of weeks, I'm going to lead you through all the stuff in the first module, and we'll talk about that a little bit more in a moment, partially just to give you a feel for the other stuff. A lot of this stuff is fairly complicated, and I think it helps if you actually see it done and help do it. Does that make sense? If you can't be here, I will record it again, and there are already recordings there. But we're going to do the first assignments together to give you a feel for what the class will be like. Does that make sense? Because, as I said, databases are complicated. That's one of their drawbacks. It also can be part of the fun part of it, depending on your point of view, I guess. I don't know why BTM11. I don't care. Basically, that means you can open up Windows. So I'm Steve Conger. Some of you know me, some don't. My office is literally right across. So the main offices are there, and the first one over here on the corner. And my office hours this quarter will be primarily Tuesdays in the afternoon, because I have a class in the morning, and Thursdays in the morning, because I don't have classes on Thursday. If you need me other times, appointments work, or you can just tell me that you need to see me and we can figure out a time. Okay. So, you can come by if you have problems. We're also going to be lucky this quarter to have Peter, and let me say your name right, Puba, as tech TAs, so they can help you as well. So if the class is busy, you aren't dependent on me getting from person to person, which can take a while. So there'll be a couple, 3 of us here. I wasn't sure to say it right. So my email, stephen.conger@seattlecolleges.edu. If you contact me through Canvas, it goes there. Everything you do in Canvas ends up in my email anyway. So I do answer emails, particularly since we're only 1 day a week. I do answer them on the days that we're not in class. I do answer them on the weekends, although I don't promise instant response on the weekends. I usually check my email a couple of times a day on the weekends. I do my grading typically on Sundays because I'm a procrastinator. So if you don't see something graded, wait, if it isn't graded until on Sunday, they usually do that by then. Okay, so things that we're going to do this quarter. Basic database terms, just get some of the terminology down. We're going to talk about the advantages and disadvantages, or at least think about them, of various database systems. We're going to look at 3 databases in class, really. We're going to look at MySQL, which we'll talk about that a little bit more in a bit, but that's a really popular database, particularly for web purposes. It's a really good content manager for the web. It's used by WordPress. It's used a lot on the web. We're also going to look at Postgres, which is a much more sophisticated but open source database. It's gaining a lot in popularity just in the last few years. It's been around. It's older than MySQL. It's more sophisticated than MySQL. Because of that, it was not as popular for web-based things because it required more to learn it. It wasn't as easy to just instantly set up and run. But it has better security model. It has a better SQL model. It has all sorts of features that I think are better than MySQL. But MySQL is still a really popular database. So those are both relational databases. And then we're going to look a little bit, just kind of at the very end, we'll look at Mongo, which is a non-relational database. We'll talk a bit about what that means later this period in terms of what's relational versus non-relational. But I wanted to give you a feel for that because non-relational databases are making a big headway in the industry. I don't think they'll ever replace relational databases because what they do is really different. But most companies have both and use both in different ways. All right, so this is being a hybrid. As I said, we'll do mostly, once we get through the first module, once I've led you through that and you've got to see a little bit about how you do database design, how you do the relational diagrams and things. Once we've gotten through that, it will be mostly open lab. If I find a point where we need a lecture because everybody's floundering, I will put a notice in Canvas that I'll be doing it. And again, I'll record it so that if you can't be here, we'll get it. I did order a textbook this time. I don't usually, but I did this time. This is a pretty good book. It has, we're not going to use all of it. We'll use bits of it. I ordered it because I thought it might help get some of the theory and some of the ideas down. And one of the things, when you look at the modules, you'll see that there's reading suggested for each part. I ordered it partially because the other sections of 220 use this book too, at least Nicole's sections. And it's not horribly expensive. This one says it's $54. I'm not sure. You can probably find it used too, or online for cheaper. I don't know. I haven't looked, but I think you can. The typical database book, and if you want, I could go get and bring some of them in there, is usually a thick, big book. It's usually meant for like a third year computer science degree. It usually covers a lot of stuff that I wouldn't bother covering, like relational calculus. I mean, they tend to be really big, really expensive, through $200-300, and cover a lot of other stuff. If you want to look at some of them, I'm glad to lend them for a bit if you want. But this covers the basics of design, and that's really what we're focusing on. How many of you have worked with databases? A little bit? Done some relational design and all of that?
I've worked with MongoDB.
Oh, so it's a different non-relational design, yeah. So maybe you can help when we get there. I don't do a lot with it, a little bit just to show the JSON. We will, I don't know if this is of interest to you, but I did a Twitter scrape for climate change as a keyword, and I have about 270,000 records we can import and look at. But we don't do a lot with them, we just look at them. So, as well as the book, as I said, there are all those videos that I've made, and I'm not a great video maker, just to let you know. And then there are the blog, and then there's also a lot of tutorials and stuff online that you can do. And maybe one of the things that we can do as we go on is make a discussion where we add resources if you need, that you find it useful. Okay, so as I said, we're going to use MySQL with Workbench, Postgres SQL with pgadmin, which is just its front end. It's most of these, MySQL is the server. It runs as a service in the background. Workbench is just a front end that gives you a graphical way to deal with it. A lot of database administrators ignore the graphical and do it all from the command line, but I'm not going to make you do that. Same with Postgres. Postgres is a service in the back end. PG admin is a front end, visualization of it. And then we will use MongoDB, and I said with Compass, but actually with Mongo I probably will stick a little bit more to the command line. It's easier. Compass is clumsy. So but it does give you some visualization of what the data looks like. So a couple of things else on the assignment. So I said we're going to do the first module together. The dates on the assignments are approximate. They're my best guess when the quarter starts. So we may be a little bit behind or we may be a little ahead as we go through. And that's okay. Particularly since once we get going, it's kind of on you with the open labs. However they work, as long as they're done by the end of the quarter. Couple of things. I do not, because I consider the dates approximate, I do not take off for late assignments, right? So if you get a little behind, you don't have to panic. You can keep going. What I really beg you not to do is to turn everything in on the last day of finals week. For a couple of reasons. One is it makes me cranky. Two, when I grade assignments, if I take any points off, you can redo them, and you can get those points back. If you turn them all in at the end, you don't have that opportunity, right? So there's no fixing it if there are things that are wrong. And because I'm probably crankier at that point, I may be more likely to take points off too. So try not to turn it all in at the very end, all right? They don't have to come in on the day that they're due, but try not to. And for your own sake too, it's a nightmare to try to do the whole class in the last week. People have done it, and it's why put yourself through that much stress? I know you're doing lots of classes, and one of the problems with me not doing due dates strictly is that the other dates are strict. So there's a tendency to do everybody else's work first, and I understand that, but don't let it go too far. Does that make sense? I will try to be good about letting you know if I'm seeing somebody falling farther behind. But you can also talk to me if there's a reason why you're falling farther behind. Talk to me before it gets desperate, right? And if you're not understanding things, talk to me too, right? Don't let it. It's fine. This stuff is complicated. You are not born knowing how to do it. It is not something you should be able to just intuit. It's a learning curve, and it takes a while. And if you're having a problem, sometimes talking it through can help. Okay, these are supposedly the kind of grades. You notice that I give lots of room at the top. That's actually not school standard. But mostly if you get all the assignments in, that you probably will get the 4, right? It's usually if you don't turn in the assignments that you don't get the 4. And I shouldn't say this, but giving that range, basically it allows you to miss one assignment without a penalty, essentially. But you don't know which assignment you want to leave probably until the end. So there's a whole bunch of other information in the syllabus, which if you want to look through, there's land acknowledgement, accommodations, Title X, equal opportunity, all the kind of legal and social stuff that you might want to look at. It's there if you want to see it. Any questions on the syllabus so far? Trying to think if there's anything else that I didn't mention in there. Okay. So let's look at, if you go home, what you see are the modules. And there is a bit of a starting module. This one is actually stuff that the school, that Canvas provides. Getting help on Canvas tutorials, screenshot tutorials. Course communication. These are just stuff that come with Canvas. I left some of them in there because they could be useful to you. But that's not, this first module really doesn't relate to the course per se. We will be taking some screenshots. There are a lot of things that the only way to really show me you did them is to take a screenshot of it. I don't want you to turn in the database. It doesn't do me much good. But a screenshot of the database running can, it proves that you did it. Does that make sense? So there are some things like that that might be useful. All right, so this is the module we'll do together. Now, I may go through, one of the complaints from last quarter with this is that not all the names are clear, when I name things, so I will try to make some things clear as we go through. So I did like a reading schedule, and the first one is the worst. Because basically, one of the problems with the relational database is that it's really hard to build it in little pieces. You kind of have to know the whole theory before you start, and then you can refine it and get to go before you go. But there's a whole lot to know up front, and that's a problem. So I did, this is for the whole thing. Chapters 1 and 2 probably are the first ones to go over with this. These should be done with the MySQL and the Postgres. Now, you could go without reading any of these, but I think they will help you, right? There's no assignments that come directly from the book. The book is there just to help you. So, and then chapter 14, which is basically bad habits to avoid, is there for any time. So this is sort of the overall, the 1 and 2 at the beginning. I also put one of these at the beginning of each module to kind of suggest which ones. It's not hard reading. There are things about this book I like quite a bit and things I don't like. He tries to avoid terminology, and I'm not sure that's always a great strategy. On the other hand, it makes it less jargon intense, and he tries to explain the principles without using the terminology. All right, so let's go back from the reading schedule. So there are assignments. We're going to make like a little pizza database to start with. We're not going to ever do anything with it except for design it. But I'm going to go through a little bit of the process. And then we're going to create an ERD. Does anybody know what an ERD is? That's fine if you don't. I'm just curious. It's an entity relation diagram. And there are actually there's a lot of different versions of this, right, of an entity relation diagram. We're going to use one of the most common, Crowfoot one. But it's basically a way of designing a relational database, of showing what the tables are going to be and how they talk to each other. Does that make sense? And it's crucial that you do this kind of design with any database that's more than a couple of tables, because as we'll get into, relational databases are inherently complicated. And if you get them wrong, they don't work. And there's nothing in any of the software that I've ever encountered that will let you know that you're getting it wrong until it's wrong, until you try to use it and it doesn't work. Right? There's no warning signs, oh, you shouldn't do this along the way. So it's really important to diagram it before you actually build it. Now, one of the things that's going to be kind of missing, you can typically these diagrams are not done in a vacuum, they're done as a group. And I used to make it a group assignment. I'm a little unsure how to make them group assignments when we're doing the hybrid thing. I know I could assign them for groups, and you can work remotely, but we'll see. But it's good to talk to people, even if you're not in a formal group. It helps to have somebody look over what you've done, right? Because it'll be another pair of eyes can give you insights that you might have missed, show you things that you left out, show you things that you may have added that you don't need. Things like that. So in real life, it's almost always a group effort to build these databases. I have, so these are the assignments. Normalization and relations are an assignment 2. You can kind of see the little pins there means they're assignments. I have some Google Slides also. We're going to do a couple of those here in a minute. I generally, there are a lot of them here. There's slides and there's videos. And I'm not going to show any of the videos. When it says that there's a classroom video, that means I recorded it in a live classroom like this where I was talking. So a couple of things to know about that. There tend to be long dead spots where I go help somebody. There's background noise and other questions. You know, it's a regular classroom. So they are fast forwardable, you know, so you can get through some of those parts. There's also a couple of them, and I should try to look at them because YouTube finally returned their editing tools. They took them away for a while, now they're back. There are some that are dead for like, they may say they're 2 hours long, but the last 50 minutes is just nothing because I forgot to turn off the video. So, you know, there are things like that. But there are videos. I tried to be clear about what's, this is just a PDF on the relational model. This comes from I'm doing a book on SQL. And I actually did a book for this class too, but I don't use it anymore, partially because they charge too much for it. Well, this SQL overview we might wait on for a while, but I will do a couple of these. So does that make sense? As I said, I might rename some of these because one of the complaints is that it's not always clear what goes with what. Right. So again, this one in the MySQL, there's a reading schedule, there's a few assignments. The assignments for the two databases are pretty similar. We are going to download and install the software. You can do it on these machines. I'm hoping we have a virtual machine to do it on. If not, I can run around and give you permission. But ideally, we will have a virtual machine for you to do it on because you don't have permission to download and install on these machines. You can do it, or you can do these all on your home machines. They'll all run on anything. MySQL will run on Linux. It'll run on Macs. It'll run on Windows. It'll run on anything. But there will be a pattern. There will be a pattern where we download it and install it. There's a database here. Vincent's Vinyl is basically creating a database for a simple retail shop that sells used records. We'll simplify it a bit. We're going to say that's all they sell are used records. So there are other things we'll talk about a little bit, but we'll make it a little simpler than it really would be. There's a draft ERD, a draft diagram, and then what I will do is when you draft the diagram, I will go in and comment it fairly thoroughly. I will confess this is the part of grading in this class that I hate the most because it's a lot of work. But I will comment each diagram to tell you what you need to do to fix it. That's the final one. And then we will actually build the database. When you do queries and testing, there should be another one. Is it out of order? No, it's interesting. It must be incorporated into the or we're missing an assignment, one of the two. I'll look at it before we get there. But generally, then what we do is we'll build the database. We actually will create the database once we've done that. We'll put a little bit of data in it. Not a lot, because data entry is a real pain. Particularly if you're doing it into the raw database as opposed to into forms and, through an application. It's a real pain to do it. But I want you to do it because it's the way you see if the database is working. If you can't enter the data and you can't get it out, then you got something wrong. The testing will be a little bit of SQL. Anybody know SQL at all? It's fine if you don't, I'm just asking. SQL is the universal language of databases, relational databases. It's what you use to write queries. It's what you use to get data back. It's what you use to create database objects like tables and views. It is pretty much, and this is true whether it's Oracle or Microsoft SQL Server or MySQL or Postgres, they all use SQL. And it's about 90% the same across all platforms. That 10% can drive you nuts, but it's about 90% the same across all platforms. It's the universal language of relational databases. We will only do a little bit of it, but enough for you to get the feel of what it looks like. And we'll do a tiny bit of security, basically creating a user and a login and looking at that. Does that make sense? And then the same pattern goes for the Postgres. We will download it. It has an apartment management database. We will do a draft and then a revised. We'll create it. We'll query and test it, and then there's a security one. And then we'll do Mongo. Mongo's a little different. So we'll do that in a bit. And then there is a final and a midterm. I want to talk about them just a tiny bit, and then we'll do a PowerPoint, I think. Or they're actually Google slides. These are multiple choice. I believe they're 2 times through or 3 times through. I'm not sure which. Open book, open internet. They're really just meant to reinforce the concepts. I'm not trying to create a curve or anything. So let's look at the midterm just briefly. I just want to see if I said 3 times or 4. Oh, this says unlimited attempts. All right, we'll leave it. Time limit, unlimited attempts. So you should get all of them right. I think, again, there's only 4 questions per thing, and it's multiple choice. So it's not hard to do. And it's really just to keep like the vocabulary and terminology, just to reinforce it. So any questions on the modules there? As I said, I might rename some things just to make things a little clearer what goes with what. But no questions? Okay. Let's go to one thing I do want to do is sort of the database overview. I'm not going to do all these. These are deadly. Google Slides or PowerPoints. Too many of them is mind destroying. Yeah, I have Chrome, but I don't. I think I want to take this out. Do it as an external link. And I want to do a present. This is a little bit older, but it covers most of what we're doing here, I think. So we talked a little bit about databases. Do you guys have a clear idea what databases? How would you define a database? You guys are quiet.
Systematic collection of data.
That's as good as any.
Thank you.
I just said it's any collection of related data. Schematic is a more sophisticated word for that. Although you could get more specific. Schematic assumes that there's a structure to it, which is good. So nobody has Rolodexes anymore, but technically that could be a database, but we usually think of it in electronic terms. So I wanted just to mention a couple of things about flat files. Whoa, let's go back. So if I do, is it Shift Tab? I just want to go back. There it is. This is a comma delimited. If any of you worked with comma delimited files, you have a little bit. They're still really common, mostly for moving data from one place to another. So one of the things you can do is you can take a table in a database and export it as a comma delimited file. They're also really easy to import. They have what a comma delimited file is. These are the column names, which aren't always there, but last name, first name, email address, and notice there's a comma after each one. So those are that's how the fields are separated, is just by commas. It knows how a row is separated by the enter symbol at the end of the line. It's invisible, but it's there. And then this is, last name, first name, etc. So this has some advantages in that they are really simple, easy to transport. They're really easy to mess up too. Leave out a comma somewhere and the whole file is screwed. Yeah, extra commas can cause problems too. So I just wanted to mention those because they do still exist and they actually can be used. This doesn't happen much anymore because database technology is so cheap and easy if you're using MySQL and stuff. But a lot of times in the early days, they used to use these as the data base for a web page, because a web page can iterate through these too. So they're useful for transferring data from one system to another. I was going to show, this is a more common, it's considered a flat file too, a spreadsheet. Spreadsheets have some advantages over the comma delimited in that they are, you can do some searches, which in a comma delimited is hard. Most text file readers have a find, but that's about as good as you can get. Here you can sort, you can do searches, you can do some other things, but they do have limits. One of the first jobs a lot of people get in the database world is taking somebody's spreadsheets and translating them into a relational database, which you would think would be easy, but the structure of a spreadsheet is not the same as the structure of a relational database, and it can actually be quite difficult. What else do I want to say? I will say also that if your data needs are small, for like a small company and you've only got a few hundred records, a spreadsheet might be your better choice. It's a lot less overhead, a lot less work. But when your data needs get to be large and complex, spreadsheets get to be more of a problem. There used to be a limit on to how many rows you could have in a spreadsheet. With Excel now, though, it's like in 3 to 5 billion, which is still smaller than a lot of databases, but it's pretty big. But if you had 1 billion rows in a spreadsheet, I think it would be quite cumbersome to do. Also, it's not uncommon to have several spreadsheets that have to work together, and there are people whose whole job is taking data from one spreadsheet and another and trying to bring them together into analysis. It's a painful job. So anyway, spreadsheets, another kind of database, but there are advantages and disadvantages to these. Again, flat files are lightweight, they're easy to use and transport. One of the difficulties of a server-based database, when we get to it, the relational databases, is they're not meant to be moved, right? You don't put them on a thumb drive and carry them somewhere else. They're generally just text files. That's not true of a spreadsheet, although they're XML files now. And they don't generally require special software. Again, that's not entirely true of a spreadsheet, although Google Sheets will read Excel fairly well, and Excel will read Google Sheets, and I think OpenOffice will read them both too, so they're fairly compatible. They're generally humanly readable. One of the things about relational databases when we get there is the files are not readable by humans. And even the database structure isn't always readable by humans. Okay, disadvantages. There's no data type enforcement. What that means is that there's nothing that, if you have a column of dates, there's nothing that makes guarantees and enforces that every single column will be a date. Or if it's text, that every single column will be text. Or if it's number, I mean, there's no enforcement that the data type is consistent all the way down. There tends to be a lot of redundancy. Do you guys know what I mean by redundancy? Kind of says it there. Data gets repeated. Repeating data can be a problem because if you enter somebody's name, say every time they come in and make a purchase, you enter their name into the spreadsheet or something. If you enter their name 50 times, but you misspell it 3 times, those 3 times won't show up when you do a search for that person. Computers are very literal, right? So the more times you enter something, the more times you have to make a mistake. As well as just kind of wasting space. And it's generally hard to query data, especially when it crosses multiple files. So those are the disadvantages. Questions? So this is a type we're not going to deal with much at all, but they still exist. A hierarchical database. Has anybody ever worked with anything like that? They still exist primarily in large institutions such as banks, insurance companies. The reason is that in the 1970s, they paid millions of dollars for their databases, and they're not going to get rid of them until they no longer function at all. They tend to be written in COBOL or Fortran. They use flat files for their data. They're not relational. They're really structured like a file system. So there tends to be a root, and then there tend to be branches, and then branches can have sub-branches. So it's a lot like a file system in Windows or Linux anywhere. And there are some advantages to that. They are easy to navigate. You know how you can kind of iterate through a file system? It's pretty fast. Hierarchical databases were, until the hardware got a lot better, faster than relational databases. That's sort of that. So it's easy to navigate, relatively fast. The redundancy, the difficult, they tended to store things in multiple places. So say it was a bank, it had one of these, and you had a checking account and a savings account and a loan. They might enter your whole information, just kind of repeat it in all 3 places. So say you moved and changed your address. They might change it in 2 of the places and forget the 3rd. And so you suddenly get a bill that says you haven't paid these things for months because they've been sending it to the wrong address. That used to happen more than it does now. Again, relational databases tend to not let that happen. It was also difficult to compare data across folders. They had to write a new COBOL program if they wanted a new query. I haven't seen him for a long time, but there was a guy on the train whose job was to come in and write COBOL queries when the bank needed a new query. They basically, because there's no built-in query language, it was just you just add to the program. I don't know if it's worth mentioning. The school, not only Seattle Central, but actually every community college in the state of Washington, all share in a hierarchical, Unix-based, COBOL-based database that's on a computer. They've been working for decades to try to get it out of that database into relational databases. Most recent attempt is to get it into PeopleSoft. We'll see what happens. The schools that have tried it so far haven't been happy, but I think it'll go anyway. Again, it's because they built this up in the 70s. It's a really massive database because it has 33 community colleges, all the faculty information, all the payroll information, all the students from all of those colleges, all of their registrations and history. and grades. It's a gigantic, complicated database. All right, so this is where we're going to focus most of our attention. Relational databases. They're fairly ancient as far as computer things go. They originated in the 1970s. All right. I don't say it here, but they were primarily the brainchild of a man named Codd. Have you guys heard of Codd? I think it's Edgar Codd. An odd name, but he came up with 13 rules for a relational database. Things like everything has to be in a table. Tables are related by primary keys that are repeated as foreign keys in the other table. That there should be a sub-language that does everything, like SQL. I mean, he had 13 rules that are basically still the foundations of relational databases. He worked at IBM in the 70s. So the thing with relational databases is that all the data is divided into separate tables. Right? Each table should be about one thing. We'll talk about that more later. Information is only entered in one place. So if you have a person's address and person's name and stuff, there should only be one place in the whole database where that information is entered. You never repeat data in other tables. It's always, all you have to do to refer back to get that address is look at their primary key, usually a number, like a customer number or something. So in a sale, they don't repeat your name or address or phone number. They just give the customer number, and if you want to figure out who that is, you go to the other table where the customer's stuff is related, is spoken. So nothing is ever repeated except primary keys as foreign keys. That's the essence of it, and we'll spend weeks on it. So you'll get a feel for it before the end. I think I have a sort of this is an example of an entity relation diagram, although we're going to use crow's feet instead of keys. So each of these, what an entity is just a table in waiting, basically. These are not tables yet. They're conceptually, they're called entities, but they will become tables in your database. Notice that these are just this is for like doing reviews of books. So we have book key, book title, book entry, book ISBN. It has a key field. Over here we have authors. Author has a key field and author name. And I have a table linking author and book where it has the book key and the author key. And the reason for doing this is that one book can have several authors, and one author can write several books. So this is how you create that kind of relationship. And you can see that it's a little complicated. One thing that seems to go together just fine is three things. Does that make sense at all? I think I have the next one actually shows. This is like a list of authors. They have a key, which in this case is just numbers. I usually use numbers for keys, just auto number them, but you don't have to. You could give them some variation of their name or something as a key. The trouble with that is trying to maintain uniqueness. Trying to make sure because one of the things about a primary key is it can never repeat in that table. It has to be absolutely unique within that table. That's easier to do with numbers than with words, but you can use words. So these are the names of the authors. Down here there's their books. So here's the Elegant Universe, and it has the ISBN. You could use the ISBN for the book key too, although not all books have ISBNs. We won't go into that right now. And then it's only an accident. In this table, see there's 4 and 4. The book is 4, and the author is 4. They don't have to be the same number. They could be, different numbers there. It's just that I happen to enter them in the same order. But this one refers to the book, and this one refers to the author. Notice that this table is nothing but numbers. If you were a human and you just opened that table, you wouldn't be able to make heads or tails of it. It's just a bunch of numbers. Relational databases are written for the computer, not for you. When you do SQL, the language and create forms and things like that, and other, like web forms and stuff. All of that is to bring the data back together in ways that make sense to the human. Here, in the relational structure, is just made to make sense to the computer. And the computer can resolve this. The computer can go from here to here, and from here to here, and it can figure out which, and nothing's repeated except that number, right? Not that you need to know that, but one reason why relational databases work so well on the computer is that they are mathematically based. They're based on set theory and trying to think of the other.
First order.
What?
First order predicate logic.
Yes.
I
Thank
read
you.
the book.
You read the book. Yeah. So first order predicate logic. So I was thinking predicate, logic. They also can use, although we certainly are not going to do this, they also sometimes use algebraic and calculus to describe the relationships. The only point of all of that is because it's mathematically structured, computers do really well with it, because computers, for all the things that we do with them underneath, they're still just calculating machines. They're just really fast calculating machines. All right. So a couple of things about database management systems. One of the principles of a relational database, and this is something Cod had in the first 13 rules, is that the structure of a relational database is the same. The logical structure is the same no matter what product you're using, no matter what system you're using. So structure of a relational database would be the same on Oracle or SQL Server or DBase or MySQL or Postgres or any of the others. There are several other databases that could be out there. These are different commercial products, right, that run relational databases. We're going to look at the last two. Oracle was one of the first, and it is certainly still today the biggest. We don't do Oracle just because basically you have to teach their curriculum if you're going to teach it, and Oracle costs a lot of money, and you're not going to get a job at Oracle until you have many years of experience. So that's one reason I don't teach it. It's definitely a good database. Amazon's main catalog is based on Oracle. So if you think about what a database can do, think about all the people querying Amazon at any one moment. Millions of people querying it simultaneously, looking for billions of different things. So Oracle is very powerful. It's also extremely expensive. An installation like Amazon's probably costs millions. SQL Server is Microsoft's. And it has power somewhat comparable to Oracle. It's way more popular on the West Coast than on the East, just because of where Microsoft is here. Oracle is on the East Coast. Again, it can do all the stuff that Oracle can do. I mean, basically, it's a massively powerful server. I used to teach SQL Server, but a lot of people complained because they couldn't get it onto their Macs. There are free versions of it, but it also is, if you pay for it, it's extremely expensive. I haven't looked recently, but I do remember numbers in the realm of $20,000 per processor. I know that the Port of Seattle has a massive SQL Server installation. How do I know that? Because if I ride the commuter train every day, and half the people there work at the port or at Amazon, so if you eavesdrop, you hear lots of conversations. DBase is IBM's relational database. It's not as common, although there are a lot of installations out there. It's typically the people that have DBase are the people that have IBM doing their IT for them. Does that make sense? They install that. It tends to run on Linux. I think it'll run on anything, but it's usually with an IBM setup. What they do is they give you a stack. Instead of mainframes these days, they give you stacks of Linux machines. MySQL we talked about. We will look at it. MySQL is probably the most popular database for the web. I'm not entirely sure why it got to that status, but it's really good for content management, and it's fairly fast. It's especially fast if you use there's ISAM, and what's the other file system? Does anyone know? There's two file systems. One file system cheats. It doesn't do any referential checks. So it doesn't test to see whether things are related properly. It doesn't test to see if things are repeated. It doesn't test for anything, so it's really fast. Probably if all you're doing is just pasting text from the database to the web, that's fine. If you need any kind of, there's another database file system that MySQL is actually using as the default now, which is ISAM, that does do the checks, so it's not quite as fast. Postgres, as I said, has been around. Postgres has been around forever. Supposedly UPS uses it as their primary database for delivery and stuff. It's older than MySQL. It might even be older than SQL Server. They've been developing it for years, but I know because I've met a few of them that one reason why it's probably not as popular as MySQL, other than it's richer and more complex, is that they were very, what would you call it, arrogant. They figure anyone that needed something more than a command line was a waste. But they have developed front ends. The PG admin is pretty good, and we're for what we're going to do. It's easy enough to use actually too. There are others. There are lots of others too. Any questions on that? So one of the things I just want to get. So when we do MySQL, the structure of the database is going to be the same if we were to do it in Postgres. That doesn't change. They're just different products that implement the relational standards. Does that make sense? Just different companies. How do they make money? MySQL and Postgres make money if you pay them to consult. Right, so you do an installation. So if you do a big commercial installation, you probably need some support. And they get paid for the support. I don't know if they make money other ways. All right. So, a couple of advantages and disadvantages of relational databases. And then after this, we might take a break because I see a lot of yawning. So, the advantages here are they offer relational integrity. That means because the data is only entered in one place, you can be fairly sure that the data is accurate. I mean, there's tests and checks to make sure that the data is consistent and accurate. You don't repeat it in more than one place, so you don't get those kinds of errors. And there's part of the primary key, foreign key thing that we'll be talking about a lot is that you can't have a foreign key that doesn't exist as a primary key somewhere else. That means that there's a check that you can't have an order that doesn't have a customer, for instance. You can't order a product that doesn't exist. You know, there are all these things that help keep things honest inside the database. Relational databases are pretty easy to query. You remember one of the problems is that they're hard to query. Any piece of data that can, in a relational database that's well designed, you can literally relate any piece of data to any other piece of data in that entire database. So you can make really complex analysis of your data in a compared to non-relational databases, it's easy. You know, it's fairly easy to do really complex analysis. The biggest drawback is that they're complicated. Because of the way that the data is broken up into separate tables, because of all the relationships that must exist between those different tables, they are really complicated. We are going to deal with like medium complexity. Our databases will have between 10 and 11 tables probably. That's not a lot. Some real commercial databases have hundreds of tables. Although I will say that a lot of those were probably added spuriously after the fact. But they get really complicated. That's a drawback. And it can be really easy to make a bad database. Right? The software doesn't protect you from making a bad database that doesn't work. You find that out by using it. Another thing when you're building databases, if you're doing it, you should test it a lot before you deploy it, because it's a real pain to try to fix it when it has live data in it, because you could lose some of that data or have to. Questions on that? The complexity can be fun. It's like a puzzle. If you like puzzles, if you like logical puzzles, because it is logical, it could be fun. It can also be frustrating. Just as a warning. So just a quick few notes on NoSQL, and then, as I said, we'll take a break, and then we'll do just a couple of things to start getting through the rest of the module. So NoSQL databases are a new thing. For years, since the 1970s, there have been attempts to try to create databases that weren't as complicated as relational databases, and they mostly failed. NoSQL is the first one, or the first databases that have sort of made some inroads. So there are a couple of things when they say NoSQL. There's a couple of things that it's different than relational databases. They tend not to have rigid table structures. In a relational database, it's a grid. It's a two-dimensional grid. You have column headings, and then you have data under those columns. Every record in that table has exactly the same structure, right? You can leave things empty if you don't have information. You can put nulls in there for things that you don't have, but every record has exactly the same structure. In NoSQL, you can vary the structure a little bit if you need to at different times, right? They put them into basically collections of related structures, but not necessarily identical structures. Does that make sense? What it's good at, really good at, are things like social media. If you think of a Facebook page or even a Twitter tweet, it could have an image or it might not have an image. It could have a link to a video or not have a link to a video. It could have text, and the amount of text could vary, right, depending on things. It could have, you usually keep track of likes and other references, tweets. You keep track of subtweets. You'd be surprised how long a Twitter record is in JSON. JSON is, by the way, JavaScript object notation. It's like 70 lines long. The tweet is just 253 characters or so, but they keep track of who did it, if it's been retweeted, who retweeted it, what region does it come from, what language was it in originally, does it have an image? It keeps track of all of these different things for every one of them. And because those things are, each one is structured differently, but they're still kind of related, NoSQL is really good at that. They're also really good at scaling. But with that, I mean, so with a NoSQL database, you can, they call it sharding, but you can put disks all over the internet. Anybody that wants, you can have thousands of different disks storing the data. So it's fairly easy to get into terabytes of data without a lot of pain. In a relational database, if you want a bigger storage, you buy more hard drives. Right? So you basically you have to manage all your hard drives, and they all have to be related to each other. They can't be scattered across the web generally. So if you want a gigantic SQL Server database, you buy a bunch of hard drives and just keep spreading the file across them. With NoSQL, you can scatter it across the web. there are some disadvantages of that too. Actually, before we do that, I'll leave it there. The disadvantage is that a NoSQL database that's spread across the web never guarantees that you're going to get the same answer twice, because they actually use a algorithm that was developed for Google. Goes out and finds all the information that it can in a reasonable amount of time, and then pulls it back. It doesn't get all the information because that would eliminate the reasonable amount of time bit. And so when you have your data spread across the web, it goes and hits all the hard drives that it can to get that data back. But if there are pieces beyond reach or that are down for the moment or something, it just ignores them and brings it back. So that's, again, perfectly fine for social media kinds of queries and for things, for some of the looser kinds of data, and does allow you to store massive amounts of data for low expense. But it's not particularly good if you're doing accounting or, point of sale. That being said, there are people that use NoSQL for those things, but they probably don't spread it across the internet. They probably keep the disk local. And all of the logic to keep things, the integrity of things, to make sure that there aren't any duplicates, all of that logic is in the application, the software that you write. It's not on the data in the database. So this is an example of JSON. It's very different than a relational database. This is a real simple one. This is just curly brace, curly brace. It's basically key value pairs. So you have a key. Now, if you don't do all in Mongo, everything is an underscore ID. You can assign it a value or it'll give you a value. Probably in general better to let it give you a value. But it's different than the keys in a relational database in that generally you don't use them to relate to anything. It just gives a unique stamp on each record. And there's no mechanism to make it relate. That would be entirely up to you. So here's a key, and then there's the value, so colon value, key colon value, key colon value, key colon value. It can be a lot more complicated than this because you could have a key that equals another object that has keys and objects. I mean, it can be really complex. But JSON is really popular also because browsers understand JavaScript, right? Browsers don't, they understand HTML and they understand JavaScript. Everything else requires an interpreter for the browser, but the browsers are built understanding JavaScript and HTML. So to transfer data to the web, to stuff with this is really easier than other ways. It's a real easy way to handle data for the web. Does that make sense? And again, they're good at capturing data. They're good at handling big data. They're not particularly good at business transactions. They can be used for that, but all of the safety is based on the programmer. And I think that's it for this whole thing. So, any questions? That's just an overview. Let's take a break, and then we'll do one more thing, and then we'll call it a day. How was our time? We got about an hour. So let's take a break till about 10 minutes. If you don't want to take a break, you don't have to, but it's hot in here and people are nodding off.
That's why it's 4 minutes different from this.
Yeah, I think it's probably more.
Right. I just checked my phone.
Yeah. I've noticed that in the past. The server is weird. Let's see if I can pause the video. I think that'll be recording now. Just real quickly, I wanted to show a little bit of what a database looks like. This is Postgres. This one we'll do last. It has a bunch of objects up top here. This is called the object browser, basically. And it just shows, come on in. It just, we're not going to spend a lot of time with those. Those are neat things you can do with it. Down under schemas and public, if you go down, there will be where the tables are. And this one has 14 tables. I'm not going to spend a lot of time on that. I just want to show a little bit of how the data would look in a database. So I'm going to do a little tiny bit of SQL. I'm going to select asterisk, which means select everything. And I'm going to select it from the table person. All right, so this is an actual table that's in here. There's person. I already have it open where you can see what the columns are. If I hit the little lightning bolt, it'll execute that, and it'll show me all of the people, their last name, their email, their phone number, etc. So, and all the people in here are recorded in person, whether this is like for a charity that loans money to people temporarily, actually gives money to people for one-time needs. I don't know if such a charity actually exists, but so the people, whether they're asking for money, whether they work here, whether they are donors, are all inside here. Yeah. So you can't. Once you have it all downloaded, you can. I have it on my machine. It's not on your machine, so don't. Yeah. When we do the second database, you'll have something that looks like this. It's pretty easy to download. It's just Postgres. But there are videos for doing that. I'm also going to do, just real quickly, select star from employee. So some of these people are employees. And if I execute that, notice that this table, though, doesn't have any names or anything in it, right? It just has the employee key and a person key. So the person key will tie it to the person table. This is how it's tied. This table isn't particularly readable, right? And I'm going to show you one last thing, just to show you again how these relational databases. So if I wanted to see what people were employees, I could do select, let's do like person last name. And again, this matches here. I think actually if I did, nah, that doesn't work here. Oh, I can drag it though. All right, person last name. And then let's give their email too. It's nice to drag when you can. And I'm going to do it from person. But I'm going to join it with employee. With is not a word there. And I have to tell how those two tables relate. Person.person key equals employee.person key. So what I'm just kind of showing is in a relational database, this table is essentially unreadable to humans unless you flip back and forth to figure out what the numbers mean. So I'm going to run just this part, and what it'll do is it'll show me which people are employees. Right? So it brings that information up where it's readable. I could also, if I wanted, and put in like the employee key here so you could see which employee they are. What did I do there? Why did that do that? Yeah, I know, but it's not working right now. All right. So it has the employee key. They're not necessarily in order. I think that it's ordering. It's not ordering by name. I'm not sure why it's ordering by. You can sort these too. I didn't.
Could you sort by ASCII key?
Yeah, we could. We could say, again, this is down the line. I just wanted to do a quick demo. Order by person, last name. If you don't give any other arguments, it assumes that you want to order alphabetically or in normal numbers. And now it's entered, you know. It's in alphabetical order. That's SQL, if you're interested. Mostly I wanted to show what a database looked like, that it's basically a grid, column names, and then the data underneath it. All the data in this has to be a last name. It's all characters. This is also all first names, all characters, and all emails, all characters. The field name is integer, right? Just a number with no decimal parts. Okay, so that's just an example. One of the reasons to show this now is when we do diagrams, the only part you're interested in are these headers. When you do a diagram of the table, you don't worry about the data that would be contained. You only worry about the headers. Does that make sense? Because one of the things that's easy to confuse is data and headers. A lot of people, when they do their diagrams, start putting data in the diagram, and it doesn't work that way. All right, so let's do the first assignment. And then I think we can do most of the remaining assignments next Wednesday, right, for the first module. If we don't get them all done, we can continue a little bit into the next. But so let's go back. This is a real easy one. Now, before, there is a PowerPoint or Google slide that would be good. I'm not going to do it because we've had enough of those, I think, today. But there is a process that goes along with creating a database. One of the reasons I don't use the book I wrote for this anymore is it really focused on that process, which is important. But the effect of it was that we only built one database during the quarter. So I just want to real quickly talk about what that process is. Typically, there's the realization that you need a database, or somebody hires you to make a database. What do you think you would do first after that? I'm just speaking of brainstorming. We'll brainstorm this a little. Well, first you talk to people, right? First you would talk to the manager or whoever's in charge of the thing that needs the database. If it's just you building it, then maybe you talk to yourself. But you talk to the people that are going to do the database. You need to get an overall picture of what that database is going to do. You don't need to, when you first start out, you do not need to worry about what software you're going to use. You aren't worried about the table structure that you're going to have. You aren't worried actually too much about the specific data yet. You just want to know, what is this data supposed to do? What is this database supposed to do in the broad sense? So you get that clear. Then you go out and you start doing things like analyzing all of the existing forms. Forms could be electronic if they had a previous database or something, or it could be receipts, order forms, things like that. All this stuff is relevant to the database. And when you look at that, you can go through the fields and you decide all the stuff that is on those forms are probably things that are going to have to be in your database. So you start collecting that. Then you start talking to all the people that are going to be working with it, that have worked with the data as it exists now, that will be working with the database. The thing is, it can take a long time to go through this process. And then you start, after you get everything together, you start doing the diagramming. And then when you diagram it, then you have to go back to all these people and say, did I get it right? Did I forget anything? Right? And then once that's all cleared up, in the very end, then what you do is you start creating the database. And even that thing along the way, you need checks. You need to check with people. Does this look like what it should? So that process is important. The book here has a little bit about that process. But and there is a Google Slides here. And as I said, what I used to do in this class is I spent the first 2/3 on that process. But I think as long as you know that it's important, we'll spend more time on actually developing the databases. All right, so this assignment, this first one, is a substitute. It's an unreal substitute for all of that process. We're just going to brainstorm what would be in a database to handle a pizza shop. And again, let's keep it a little simpler than a real pizza shop. So I have here, right now, what we're just going to do is just what kinds of things would you need to know about for a pizza shop? And this is just pure brainstorming. Second thing we'll do, whether we get to it today or not, is to organize it, right? But right now we just want, and this brainstorm is a substitute for months of interviews. So what do we need to know for a pizza shop?
Toppings?
Toppings. What else? Sauce. Crust. What? Sides. All right, so that's the pizza. We went immediately to the pizza. I can understand that. I'm hungry too. Did I do not? Oh, size.
I'm sorry. Where are you at right there?
This is a notepad. And I'm going to post this on the blog where you can copy and paste it for your assignment if you want. So, and in fact, I'll show you how to do that. What else when we're done? Customer, yes. Price is actually a good thing. You might have, yeah. Are drinks different than sides, I guess?
Employees?
Employees. What else?
Delivery method.
You might want the delivery method. Delivery. What else?
Special requests.
Maybe. I'm going to put that in parentheses. So one of the things that I would say is that, yes, in real, do we want to do that? I'm not sure. And it might be a different database. So you might have one for those kinds of, yeah. Oh, I'm not worried right now about how they look in the, we will eventually create a diagram out of this. But you're right. Oh, I see what you mean. So should we do commas? Because you were thinking method could be different than delivery. So there's a whole bunch of stuff here that could be there. The other thing I'm going to say with employees is we probably don't, for us, want to do the whole human resources. Does that make sense? Because that's a whole complex database in itself. What else? Anything? So when you think about customer, some of these probably have other things that go with them. So for an example, a customer probably has a name. What else? Address.
Payment method.
You might want payment methods, yeah. Probably do. Probably want the customer phone. If you're doing deliveries, usually you need the phone number. You might want their email. What? I didn't hear.
I think you said orders.
Oh, yes, actually, so the whole order, right? What's in the order? That's actually very good.
Like ovens and
Maybe you're thinking about,
Yeah, that's more infrastructure, I guess.
yeah. I'm going to put it in. So it is possible that these would be in a real pizza. Has anybody worked at a real pizza place and done a pizza database?
Monthly sales, weekly sales.
So actually, I will put that in parentheses too. Can I say why? And although actually, you shouldn't. When you're doing this kind of brainstorming, you shouldn't worry about this. But generally, summary information you don't include in a database because you can just write a query to get that summary information. But that's fine, actually, because you do want to know that one of the things that the database has to be capable of is you have to be able to get the monthly sales out of it, right? Which means that you have to have some things in there like dates for, sale dates. You're going to have to keep track of when the dates are, because otherwise you can't get monthly sales. When I talked about forms, there's also another thing you can look at, like reports. What kind of information do they need out of the database? So they'll probably need monthly sales. They'll probably need sale numbers, right, for each, all sorts of summary information about the sales. I don't know, there could be other things. This is a slippery slope, but maybe inventory. Inventory could be complicated too, but
Boxes.
maybe boxes if you're doing inventory.
Put pizza in something.
Promotions is actually not a bad idea because if you're promotions and discounts, I'm going to put that together. And you probably would want to report on how effective these promotions or discounts were. What else? Anything?
Nutritional information?
What?
Nutrition information?
Attrition? In terms of employees or what?
Like nutrition, like how much calories pizza has.
Oh, nutrition.
Yeah.
Maybe. I think if you're a big enough chain, it requires it.
The locating number for when you start to work.
Oh, so the employee will probably have a number, right? I heard something over here.
Employee schedule.
Maybe. Schedule is a hard thing. We could maybe do that.
Tips.
What?
Tips.
Possibly. Although, do they track that for? I mean, most restaurants that I know do their best not to track tips. What? I still didn't hear. You might, although, we could argue, so let's put that in here for now. Because one of the arguments we can have is what do we want in there, what do we really need? But, that is an important part about the restaurant. Does it need to be in the database? I don't know.
How about
Location? Location would matter if we're talking about multiple sites. Does that make sense? Yeah.
Product,
Like which?
like inventory, I guess.
Yeah, so within inventory, there'd probably be different products, yes.
Loyalty numbers, that's my loyalty points.
Okay, so if you're giving people, so let's do it, customer loyalty points.
vendors?
That's actually a good. I will say that this is starting to scare me for working it out but it is fairly real. Okay, vendors you probably would want in there in terms of and probably related to the products. Maybe. So when we build our diagram, we'll have to decide how much of this we want. I would be curious. So, I don't know that I've ever seen an actual pizza shop's database. Most people working at the pizza shop have never seen their database either. They use it. They use it by way of forms, you know. And if all of this stuff is being tracked on the computer screens by the managers and stuff, then it probably is all in the database somewhere. That being said, when we build it, I think we'll build a core one out, and then we can decide what things we want to add. But these are good. I mean, these are good things. And again, these are things that you would, in real life, get not by brainstorming, but by talking to people. Anything else? I'm trying to think if there's anything that
Would we get into salary and stuff?
I wouldn't. I consider that kind of the human resources part. So it's not atypical that the human resources part of this is an entirely separate database, or depending on the business, they may outsource that. My daughter has a cafe in Eatonville, and they pay somebody to do the payroll and human resources stuff. Inventory with these can be a little bit weird too, particularly any place that's serving food or fast food. There's a lot of wastage, and how you account for wastage is difficult sometimes. I'll put that down. I'm not sure we'll do it. I'm not sure that's spelled right. How do you spell wastage? What?
Yep, you got it.
I got it. It looks wrong.
Google.
For the toppings and sauce, all that, we consider menu items.
So, yeah, now menu item is, we can talk about
Menu.
maybe a menu. Yeah. The database, I'm not sure if there'd actually be an item called a menu. There might be. The software that's being displayed would probably have a menu. You know what I mean? It built up of the database, but it might be built up of different pieces of the different tables.
Uniforms.
I'm not sure I would worry about those, but we could. Do they make people buy their own? Anything else? This is a good list. As I said, it's a little scary in terms of the... What?
That's a lot.
It is a lot. And as I said, we may not use everything here. And some things will expand more, right? This is just a preliminary list. One of the reasons why I'm doing this, and then, as I said, this may be as far as we go today, but once you have done all of your research, once you've looked at all of the forms and you've talked to all the people, one of the things that you can do is you can go through and take all of the nouns, basically, out of all that research and make a huge list of it, right? And then, so that's sort of what this is. And then the next stage, which we'll probably do Wednesday first thing, is go through and try to break it up into chunks that relate to each other. That's where you begin to figure out what your tables are going to be. We could do it now, but I think we'll wait. So you might end up with something like this. It's just that you would have a lot of work ahead of that to come up with the list. It wouldn't be just off the top of your head. But this is a good list. As I said, some of these things we may feel like we need to expand more because we know what they are, but we need more information about them. So, you know, what do we need to know about an employee? Maybe we only need to know their employee numbers if we're assuming there's another database that handles the rest, right? And if there's another database that handles the rest, we may not need their schedule, but we might want it, right? I don't know. We can figure that out. All right, so let's say that this is our list. I am going to tell you what, I'll save it and paste it into the blog right now, just so that I can show you how you could post it as an assignment. because we're going to do all the first assignments together. So I'm going to go to my blog. Notice that there's brainstorming here from before. I am going to, I don't want to do it here. I need to actually go to Google, to Chrome. Because I don't want to log into Google through Edge. So I am going to do a new post. I'm going to label it with ITC 220. And I am going to be really, I'm not going to format this at all. I am just going to copy it in there. This is pre is a good way to cheat when you don't want to actually format anything. Except I'll probably break this because with pre it'll run over the edges of the margin. All right, so I'm going to publish. Oh, it doesn't like my pre because it's not closed. All right, publish. Okay. So what I'm going to do is I'm going to go back to Brainstorm Pizza. But first of all, I'm going to go to Syllabus. And I'm going to go to blog. And there it is, what I just posted. I'm just going to copy this. And then I'm going to go here and we'll go to assignments, Brainstorm Pizza. I'm going to submit this. It'll go up as test student. I am going to just do text entry. I'm going to paste. And then I will submit the assignment. And that's what you can do.
Right now?
If you want, yeah. Anytime. Yeah.
You can submit a Google Doc,
Yes, you can.
and you need to add you or share the document with you.
You do need to share. So you can do a Google Doc. Actually, a lot of this stuff is really good with a Google Doc, and if you make a Google Docs to do it. But yeah, share with whoever has the link. And then when you do, I'm not going to resubmit it, but when you do this, what you want to do is website URL. And then just post the URL. Just make sure I have permissions. What I do if I don't have permissions is I usually make a note at the assignment, I can't see this. But don't do it to my email address because my Steven.com, it doesn't have a Google account associated with it. So if you just share with whoever has the link, it works. So a lot of people share it with steven.conger@seattlecolleges.edu. And when I try to go there, it says log in under that thing. And I can't because I don't have an account under that name and I don't want to make one. I have an account. If you really want to link it just to me, it's spconger@google.com. So spconger at gmail.com. That account exists. That link will work. But just sharing with whoever has the link works.
So for the next one, we have to do tonight or?
No, we'll do it on Wednesday. I mean, if you want to do it, don't worry about the due dates. Don't worry about the due dates. I was assuming we would get to it today. I don't think we will. So don't worry about the due dates. And this is generally true. The due dates are flexible, all right? And I don't take off for late. So when we go back to the assignments, so it says, I was thinking we would have time to do both today, but I talked too much. So we'll do the organized next time. We'll do the normalization, and if we have time, we'll do this. That's a lot. But next time I won't talk as much, we'll just do it together. And then if you want to do something over the week before then, what I would do, and I think this is really fairly useful. Let's go back to the modules. I would look at the gathering information, relational theory, normalization, and maybe at the videos. If you could look at that, maybe look at the book, it would help a lot for doing the next parts. I'm not going to do these slides in class because it'd be too deadening and we wouldn't get the rest of it done. But they're worth looking at, and the book is worth looking at, the first couple of chapters. And if you don't want to look at the slides, or if you need more, there's also 3 videos. There's a video on relational theory, relationships, and normalization. Normalization just is a set of rules for how you should organize your tables. The effect of the rules is mostly that you end up dividing it into smaller and smaller subsets. So if you look at those, and you don't have to understand those actually perfectly, if you just get an idea and actually come with questions, that's perfectly fine. If things don't make sense in them, don't panic. It's really early. Just come with questions, and we'll do this on Wednesday. Let me real quickly do the roster, and we'll call it good. I know a lot of people aren't here and some of them told me they wouldn't be here. Does anybody object to me putting the roster up on screen? I could shut the screen off if you do. It doesn't have a lot of information about you. So, Canella? Is that right? Did I say it right? Okay. Aaron here. Catherine? Kate. Okay. I'll try to remember that. Remind me again. One of the things I hate about doing it here, I usually print it out, because I can't write things down like Kate. But having mentioned that, I'll probably remember it. Joshua? Okay. There's me. Ash? Okay. I was debating on how to say yes. Ash is good. Purva? Oh, yeah, I know you. Why do I don't know why. Eduardo? Okay. Jasmine? Jasmine here. Jenna Lee? Is that right? Emily, she couldn't be here. She's sick. I know that. Okay, Michael. Dwayne. Okay. Pedro? Na? Is that right? It works? Yeah, but is it right?
It's
Nah. Okay. John? I didn't look to see if there are other Johns, but I assume. Debray? Okay. And that's Debray. Okay. Damila? Is that any close? Or Dan? Okay. Eunice? Aaron. Aaron isn't here right now. Aaron's another person. We could have as many as 3 people in here helping. So, because Aaron is a tutor, which is good. More people is better. Douglas,
Hi.
right in front of me. Okay. Wally, right in the back. Okay. Not. Is it not? Okay. Keiko or Kako? Kako. Okay. Sebastian. I usually do first names because for some reason they're easier to pronounce than last names. But Jesus, I assume it's Jesus. Okay. Gabriel?
Gabriel.
Is that close? Okay. Peter is here. He's one of our assistants. Isaac? Okay. Saluka? Saleka? How do you say it? Saleka? I'll work on it. Arthur, right by me. And Hong. Okay. And is there anyone I didn't call? Seems to me.
You skipped me, Dominic.
Did I just skip you?
Yeah.
Where did I skip you? Where?
Nelson. Dominic.
Oh, okay, sorry. I didn't mean to skip you. Is there anyone else? There was one person, I think, on the waiting list, and I don't know if they're here. Okay. So, next Wednesday, I will... Oops. I actually recorded roll call.